Hello everyone, I am Rajat and today we will discuss a small programming problem statement. So the problem statement is we have two shorted arrays and we want to merge these two shorted arrays into one shorted array. So this is the basic problem statement that we will solve over here. So for this problem statement, the optimal time complexity will be order of n. So this is the best time complexity that we want to derive from our solution. Here we have two shorted arrays. This is array 1 and this is array 2. So these two arrays are shorted. So in order to solve this programming problem statement, so we can solve this problem statement in three ways. One is if we directly apply merge short in these two arrays, so we can directly short this. These two arrays. If we this is so in that case, our time complexity will be order of n log n. The another approach is if we apply minimum element search category and insert this, and if we put the minimum element at a particular index, then in that scenario we can solve that problem. So in that scenario, for this approach our time complexity will be order of n square. Now there is one more approach. So the approach is if we take an extra array, and if we solve this problem, so then in that case our time complexity will becomes order of n, and space complexity will also become order of n. Why it becomes order of n? Because we are taking one extra array and its size will be equal to the m plus n. So that's why our time complexity, I mean to say, or space complexity increases here. So let's go to our solution. So third approach, take an extra array and how we can solve this program from the statement. So in order to solve that, I will put two pointers here. Let's say pointer p1 points to array 1 and pointer p2 points to array 2. Now our algorithm is like that. We will search the minimum element from these two array. If I search the minimum element from this array 1, then I will put it here and I will move the counter p1 counter to the 1 index. If both elements are same in both the array, then I will put both the element in my final array. Okay, so this is our algo, and once we have processed all elements, every elements we have processed from any array, then we will append the remaining elements from either this array or this array. I will insert all the remaining elements from the array where it has been completely processed. Now let's go to the our algorithm. So here I so initially these are my indexes 3 0 1 2 3 4 5 6 7, and here it is my index. So here array 1 have 8 elements and array 2 has 7 elements, 1 2 3 4 5 6 7. Okay, so let's process this array. So 1 and 3, which one is lesser? Obviously 1. So I will put 1 here. Now I will move pointer p1 to at this place. Now since it has been processed, I will remove it. Now again compare p1 with p2. So which one is smaller? This p1 is smaller. So I will put it here and increment it by 1 index. Now which one is smaller, p1 or p2? So here p2 is smaller, so I will put p2 here. Now p2 will point to here. Now again compare with the p1 and p2, which one is smaller? So here p1 is smaller. So as you can see, 4 5 6, these three elements are smaller than P2 element. So what I will do, I will directly put it over here, 4, 5, 6, because all these elements are same. I mean, all these elements are greater than this element. Now come, so now my P1 points to here. Now if we come, so here P1 and P2 both are equal. So what I will do, I will keep the pointer. So first I will put it here, 7 and 7. After putting that, I will move the counter. So now P1 will points to here and P2 will points to here. Now it has been processed, so I will keep in. Now compare which one is smaller. So here P1 is greater than P2. So what I will do, I will put P2 element. So 9 is there. Now I will again process it. So now here, which one is smaller? P1, P2. So here both are equal. So what I will do, again increment the pointer, or we can say counter. So here this is P2 and keep it here 11 and 11. Now P1 is pointing to 20 and P2 is pointing to 15. So what I will do, I will put 15 and move pointer P2 to here. Next, which one is smaller? So P1 is smaller. So I will put 20 here. Now, as you can see, all my elements of array 1 have been processed. Now there are two elements which are remaining from array 2. So I will append all the remaining elements from array 2 to this final array. So 21 and 27. So in this way I have processed all the elements of array 1 and array 2. Now there is one, so we also have one, we can say, optimal solution. So the optimal solution is, let's say, best scenario. I mean to say, one best scenario is there. Let's say if these two array are already sorted in ascending order. So scenario could be like this: 0, 1, 2, 3, 4, 5, 6, 7. So this is array 1 and this is array 2. So we can, so if the last element of array 1 is less than the first element of array 2, then this is the scenario where we can directly I can directly put it here and put it there. So in this way my whole solution will become will be completed in order one time. Now if I reverse it, let's say if we have 4, 5, 6, 7 and 0, 1, 2, 3, this is my array 2 and this is my array 1. So in this scenario the same algorithm applies the order of 1. So in this way we can solve this solution. So let's go to the code and we will see how we will code in the Python.
So this is a Python program which merges two sorted arrays. So what I have done here I sliced a final array and sliced these two pointer, one for first array and second one for the second array. This is length of these two array. Now there can be some negative scenarios that the length of my first array can be 0. Then I will then in that case I will return the second array, or length of second array can be 0. Then in that case I will return the first array. Now there is one more scenario that can be that one negative scenario can be. So the negative scenario is that both the length of array can be 0. Then in that case I will return the empty array. Now if there is a chance that both the array are in sorted and ascending order, so this is the scenario which handles this case. Now at the end we will go with the merging process. Now I will iterate, or I will execute my while loop until Well, until my first array pointer is less than first array length, or second array pointer, or we can say the incrementer is less than second array length. If any one of the array have been processed, what I will do, I will simply put the remaining element either from the first array or from the second array into the final array. So this is the code which does, and at the end I will return the final array. So this is the my programming so this is my program which does these things. Now let's go to the or so here I have executed my program with the various inputs. This is the first input which takes all the positive scenarios. Now here in this scenarios we are taking two arrays which are already sorted and in ascending order, as you can see over here with this input. So this is first array and this is the second array, and in that scenario one array is empty, either first array is empty or second array is empty, and at the end both array are empty. So this is whole solution is in Python. So let's execute this program and we'll see what is the our result. So here is our Python console. So as you can see, this is already sorted, and this is, so in this way we have 1 2 3 4 5. So in this is second array, so which are already sorted, and one array is empty, then in that case returning either first array or second array, and this is the case for when both the arrays are empty. So in this way I have handled the positive and negative scenarios as well. So execute your test cases and try to break my code. If you find any scenario that where my code is breaking, please let me know. I will correct it, and as well as I will share this my code with you. So the link of my code will be shown, will be mentioned in the description box. So thanks for watching. Have a nice day.